So sequencing problem will refer to, problems where we have manufacturing issues and all, especially when a particular type of a job is to be done on different types of machines. So n number of machines in a particular sequence. Okay. So if I have to do that, and where time and cost is involved, so the best way is to find the optimal solution so that the time taken to complete the jobs would be the least. Okay, because that should be the ultimate aim. So in sequencing, we are going to refer to the order or the sequence in which the given jobs are to be done, and it has to be the optimal solution. Now, suppose we have n number of jobs, and it has to be done on, say, m number of machines. Okay, so in that case, what happens is, because the number of jobs are more, there can be n, you can say n factorial to the power m, that many types of sequences which will be available, or alternatives which will be available. But trying all the alternatives are not possible at all. Okay, let us say we have two machines and we have, say, five jobs to be done, okay, on two machines. Now, if I have you can say, jobs to be done, now this five jobs can be done in five factorial ways, right? Different sequences or alternatives. But are we going to keep on, trying each alternative and try to find out the optimum solution? Not possible, right? So to do such type of jobs, we are going to make use, actually there are two ways of doing it. One is making use of the uh, linear programming method, okay, or there are different methods which are, even Gantt charts can be used to do that. But the best solution would be to make use of the Johnson rule, which is a part of this sequencing problem. Okay, so we'll see all those concepts. To begin with, let us see the first part. Let me start the slideshow. Okay, so in the introduction, I have mentioned sequencing refers to deciding the order or sequence in which the given jobs are to be performed on the given service facilities. Now, the service facilities are nothing but your machines. Okay, so suppose there are n jobs starting from 1, 2, 3, 4 up to n, each of which is required to be processed one at a time. This word is very important. It has to be processed one at a time on each of the M machines. So I have used alphabets for that, A, B, C up to M. Now the order of processing each job through the machines and their processing time required on each machine is given to us. Okay. The problem is to select the n factorial to the power m. Now this is not multiplied by m. That is power to the power m. I forgot to change it, so I'll just quickly change this one. Okay, fine, and let us play this again. Okay, so this is n factorial to the power m. Okay, number of theoretical possible sequences. Okay, that sequence of processing the job which optimizes or minimizes, you can say, the total elapsed time or cost. Now we are going to concentrate or focus on time more. Okay, so the types of problems which will be given will be based on the times. Okay, and we are going to see different types of you can say theory for sequencing problems, especially based on the number of jobs and the number of machines. So you'll see one theory where we are going to process n jobs through two machines, then n jobs through three machines, and finally n jobs through m machines. Okay, where m can be any number. So we are going to try to solve this three different types of problems for your sequencing problems, or sequencing theory also you can call it. Okay, so let us see the different terms which will be used in the sequencing problem. The first one, the number of machine, means the service facilities through which a job must pass before it is completed. Second is the processing order. It refers to the order in which the various machines are required for completing a job. Then comes your processing time, and it is the time that each job requires at each machine. Finally, we have this total elapsed time, and this is what we are going to calculate, is the time elapsed between the starting of the first job and the completion of the last job. Okay. We are also going to calculate the idle time on a machine, and we'll be doing for all the machines. So if I have two machines, then machine A and B, or if I have three machines, then A, B, C, and if I have M machines, then all the time we'll be able to calculate and give you the total idle time. Okay. And the last one, no passing rules implies that passing is not allowed. That is, the same order of job is maintained for each machine. Okay. So we are not going to change the order of jobs depending on the type of a job. Okay. So there are some assumptions which we are supposed to follow while solving such problems. And it is very important because things might not look practically, it might not look, very simple. So that's why we have some assumptions. So where we need to follow this and only then use this, you can say, theory to solve the problem. Now, what is the first assumption here? The processing of on various machines are independent of the order of the job in which they are processed on them. Okay. Then the processing times are known and they do not change. That's the other assumption. And the time involved in moving jobs from one machine to the other is negligible. That means we are considering that to be a zero value. Okay, so moving from one machine to another is considered zero. Please remember the time between the movement from one machine to another. Now, only one job can be processed on a given machine at a time. Okay, a job once started on a machine would be processed to the point of its completion on the machine uninterrupted. So there's no interruption. We are assuming that it will be completed as per the given schedule or the time given. And finally, a job is processed as soon as the concerned machine is free. Okay, but only in the specified sequence. Clear? So if the machine is not free, it has to, you can say the job has to wait, and that waiting time is nothing but your idle time of that particular, you can say, job. But if suppose the machine is free and waiting for the job to come, then that is the idle time. Okay, so depending on what we are how we are doing the calculation, I'll show you that as well. Now, for the first example of the first type of problem which we are going to check today is processing of n jobs through two machines. Okay, and we'll also take a problem and see how we can solve it. And it is not that very difficult at all, especially when we are talking about processing n jobs through two machines. Okay. Now, in this case, where we are talking about processing n jobs through two machines, the problem is we have only two machines. In the description, we'll have, say, A and B is involved. Now, each job is to be processed in the order A and B. So machine A will have the first processing and then B. Okay. And the expected processing times for all the jobs or all the n jobs on machine A, say, let us say it is A1, A2 up to AN, and on machine B, that is from B1 to BN, are given to us. And this is written like this. Okay, so this is how the, you can say, table will look like, where you will be having the jobs given to you, say A and B. Now, this will be like AI will be given to you by A1, A2 up to AN. Okay, so n number of jobs depending on n number of jobs, and B will be given like this. Okay. Now, what is the method to solve it? Let us see the method. Now, as I said, we can either make use of the Gantt chart or any other methods also possible. But because the number of sequences are very high, okay, the best method known is the Johnson rule, which can be applied to solve the sequencing problem. Okay. Now, what are the different steps? The first step is to select the smallest processing time among all the processing times, that is from A1 to AN and B1 to BN together. Okay. Now, once we get the smallest processing time, let us say there are two options. Either I'll get it for the first machine A, or I'll get it in the second machine. Okay. If I get it in the first machine, if say AR is the processing time of the rth job on machine A is the smallest, then we are supposed to do the rth job first in the available position we have to allocate that particular as the first job, depending on the available position in the sequence. Clear? So whatever comes first, and if it is the first machine, that is machine number A, depending on the sequence. If the job is supposed to be done, B will be the first machine and A will be the second machine, then we have to use this rule for the machine number B first and then A, right? So this will change depending on the sequence of the job on the machine also. Now we are considering here that A will be performed, machine A is going to perform the job first. And that's why what we check, or the smallest number which we get, the processing time which we get, if it is for machine A, then it has to be done at the beginning first. Now the opposite we are supposed to do for machine B. Okay, if suppose we get the smallest processing time on machine B, okay, let us say it is BS or the S job, then do the S job last in the sequence. Okay, so we have to put that you can say job at the end, or the whatever last sequence is available. Okay, so if it is, let us say we are doing it for the first time, we are doing the allocation. Now that will go to as the last you can say available position, to the available position. Okay, A will go at the beginning and B will go at the end, in simple words. Clear? Now there can be different cases like, the value, there is a tie between two values. Okay, so if we have AR equal to BS, then do the rth job first and the S job last. Okay, if there is a tie among AR, that means the values of A only on machine A, then do any one of them first. Okay, so you can pick up any one of them. That is what it is saying. Similarly, if there is a tie among the values on the machine B, then do any one of them last. Clear? Now we will understand this much better when we take up an example, and the example which I'll be taking will cover all this, you can say, points. Clear? The third step would be to remove the assigned job from the processing table, okay, or processing times table. And again, repeat the steps from 1 to 3. So the one, if suppose job number 3 has been already, put in the sequence, then I have to cancel that, ignore that particular column or the job, and then search for the next smallest number or the smallest processing time, and then again follow the rule that is of step number 2, that is A and B, and perform the assignment. Okay, or assign in the sequence, assign that number in a sequence. Clear? That is how we are going to move ahead. Now, this is a very repetitive job. Okay, clear? So step number 3 would be to remove the assigned job from the processing times table, and then repeating the step number 1 to 3 again. Okay, till we assign all the jobs. Okay, now whatever sequence I get after completing all the assignment in the sequence, assignment of the jobs in the sequence, that will be the optimum sequence. That means the total elapsed time in the optimal, you can say, sequence will be the least value. Okay, and that is the purpose of solving the sequencing problem, to reduce the time. Okay, to complete all the jobs on the machines which are available. In this case, it is 2 machines, in the least time which we can afford to. Yeah, that will be your optimal sequence and the least total elapsed time. Okay, we also assume that the order of completion of the job has no significance in my calculation. Clear? There's some assumption in the notes, you can see it. We also assume that in process storage space is available, and the cost of in-process inventory is either same for all the jobs or is negligible. We are assuming it to be 0, in simple words. Okay, but there can be, a higher level of problems where inventory cost is also given to you and many other information is given to you, but that is not a part of your syllabus as of now. Okay, let us take one example and trying to solve it. And please remember the steps. The steps are very important. If you miss any one of the steps, you're not going to get the right answer. Okay. So we have here 7 jobs. The job numbers are given 1, 2, 3 up to 7. And there are 2 machines, A and B. And the job has to be done in the order AB. So machine A, all the jobs will move on to machine A first and then B. Okay. The processing times for the jobs on the machine in hours are given below. What are we supposed to do? We are supposed to find the sequence of these jobs that will minimize the total elapsed time. And it is denoted by a capital T. Okay. So let us see the solution now. This is my table. Okay. So what I'll do is, now I'm going to put it in one go only, because there are 2 different ways of doing this problem. Now what you can do is, you can ignore this line here, this column, or this row, sorry, where we are giving the order in which the jobs are considered for assigning the position. You can ignore this and you can repeat the steps again and again and complete the process. Or you can make one table like what I have done now and solve the problem. Okay. But which job was assigned first or considered first for assigning in the position has to be mentioned. Clear? I'll just show you an example here. Now, if you look at the processing times given to you, the least value is 1. Okay. And it is for machine B and job number 6. Okay. That means I have to perform this assignment first. So job number 6, the order in which the jobs are considered for assigning position. So this will be 1 here. Okay. So if I move this, this will be 1. Okay. So this is the first job which I'm assigning. Okay. Where I'll be assigning this, either at the beginning or at the end, depending on the machine. Now this is my second machine, machine number B. So I have to assign it at the end. So there's one slot available here. So this will go here. Okay, so this I'll put 6 here. Okay, so 6th job will be the last in my sequence. Did you get this? Is this clear, everyone? Okay, once you do this assignment, either you can cancel this line here, column, you can put a line here and go ahead and ignore this column or job number 6 for your further calculations. Okay, in some cases I've seen there's a line given here from year to year. They draw a line and an arrow here. Okay, so a line should be drawn from year to year and one arrow should come indicating that this job is going to the last sequence here. Okay, now if this is clear, then let us go ahead. Now ignore the job number 6 and try to find the least processing time, which is, I think we are getting 3. Yes, 3 is there. But if you look at the value 3, there is a tie between job number 1 and job number 7. But as I said, both the time or both the values are for 2 different machines. Okay. So either I can, consider this, because there is a tie, I can consider this as 2. Okay. The order in which the job are considered for assigning. Either I can consider this 2 or I can put 2 here. Okay. It's up to you here. Fine. And because this is B, then the last slot which is available at the end, so this will be 7 here. Okay. And because this is 1 and it is on machine number A, it will be at the beginning first. So 1 will come here. Okay, job number 1. So I'll put 2 here and assign this job 1 at the beginning. Okay, so 1 will come here. These are jobs. Please remember this number at the last where we are putting the sequence are the jobs. And these numbers are the order in which I'm assigning the jobs. Okay. So which one I considered first? I considered job number 6 first for assigning, and I put it at the end. Then I considered job number 1 for assigning, and I put at the beginning because it was for machine number A. Okay, once we do this, we have to take this number and assign here. So this will be 3 here, and it will go as my at the end. So at the end, one is already occupied, so I'll put 7 here. This is my 7th job. Any doubts here? Very good, no doubts at all. Now the next, now I have to ignore job number 1, job number 6, and job number 7. So only job 2, 3, 4, and 5 is to be considered for the next observation to find the minimum processing time. And the minimum is 6. And you can see again there is a tie, and this time again it is for the same job. So in this case, either you can put it at the beginning or at the end. It's up to you. So you might have multiple solutions as well now in this case. Okay, there can be multiple solutions where if it can happen that, because these were 2 different jobs, then it is okay. But if it is the same job and there's a tie, okay, then you can decide whether to put 4 at the beginning or at the end. Okay, so this will be my 4th assignment, and it will be put at the beginning. So I have decided to put at the beginning. You could have put at the end as well here. Clear? So it's totally up to you. Next tie between, so if you consider job number 2, 3, and 5 remaining, we have a tie between now 3 values. So minimum is 10. So there's a tie here and here. Now this is at the beginning, so I'll go for this first and assign at the beginning here. So 5 will come here. So I get 5 here. And there's a tie between this 2 here. Now again, I can put this at the end. So I put 2 here and then 3, or I can put 3 first and then 2. Okay, it's up to you again. I'm considering 3 first. I'll put 3 and then I'll put the last one 2 here. Now the actual sequence or the optimum sequence for the given problem is 1, then 4, 5, 2, 3, 7, and the last one is 6. So I need to complete my job, okay, on both the machines in this particular sequence to get the optimum solution. Or you can, in this case, it will be the minimum time or total elapsed time. Clear? Now, what is the next step here? Now, in the problem, they have asked us to find out the total time, right? Elapsed time. Now, this is just finding the sequence. Now, using this sequence, I have to put a table like this. So I'll put a table where I have put the actual sequence which we have got now. So 1, 4, 5, 2, 3, 7, and 6. Okay. Then I have 2 columns for A and B, machine A and B, the in time and the out time for processing. After processing, it will be out. That will give me the out time. In time for machine B and out time for machine B is given. And we are also going to find out the idle time for machine B. Okay. And we are going to find out the idle time for A as well. But because it totally depends on the last job, we are not going to include this in the table here. Okay. Now look at the first job. What is the first job? What is the timing required, the processing time required for the first job? Okay, let us come back. Machine number 1. What is the job required? 3. Okay. So I'll start with in will be at 0. So I put a 0 here. After completing, out time on machine A for job 1 will be 0 plus 3. That'll give me 3. This is clear. Now, there are 2 things which will happen. As soon as machine A is free, okay, the next job will start on machine number A. So job number 4, for job number 4, in will be 3. That is the out time for job number 1. So this 3 will come here. This is one thing what is going to happen. And second thing what is going to happen is job number 1 will move on to machine number B. So the out here is at 3 hours, you can say 3 units. So in for B will be 3. Agreed? So this will be 3 here. Okay. Then the processing time for job number 1 on machine number B or machine B is 8 hours. Okay. So I need to add 8 to 3. So 3 plus 8, that gives you 11. Okay, please tell me the idle time for machine B. Anyone? What do you think the idle time for machine B will be in this case? Something in the chat. Great. Advait, 3. Exactly 3, because when machine A is processing, okay, this job, machine B is idle till it gets that particular job, right? And that's why the idle time for machine B will be 3. So here I'll put 3. I hope the first job, number 1, is making sense. Now, pay attention to the second one. The second job here will start based on the out of the first job here. And job number 4 has the processing time 6. So this will start at 3. Okay. 3 plus 6 will give me 9. So out will be 9. Okay. Now, this job number 4 will start working or going in to job to machine B, after it is completed here. But this is the time out for job 4 is 9, but job number 1 is still going on machine number B because the out is 11. Okay, so you cannot start this job number 4 immediately as soon as it is finished on machine number A. Okay, now when B is going to start the job 4 when it finishes this job, first job, and which is after 11, right? So we need to compare this out of A for job number 4 and out of B for job number 1. The one which is maximum will be the in for that particular job. So this will be 11. I hope I make sense. Okay, if you have doubt, you can ask me. Right? Then the processing time for job 4 on machine B is again 6. So 11 plus 6 will give me the next value. That will give me 17. Okay. What about the idle time for machine B here? Now there's no idle time because the out and the in is same. So 11 minus 11, right? So it will be 0. Good. Advait is giving me the answers correctly. So 11 minus 11 will give me 0. Now what about job number 5? In will be depending on this out of the previous job, which is 9. So this will start at 9. 9 plus 10, that should give me 19. Now compare 19 and 17 here. The one which is greater, that is 19 is greater. So here, this out, the machine B is free and it's waiting for the next job to come in. Okay, so the maximum is 19. The difference between this in and out of the previous job will be the idle time. Okay, so 19 minus 17 will give me the idle time here. And 19 plus the processing time on job 5 on machine B is 12. So this will be 19 plus 12, which gives me 31. And 19 minus 17 will give me the idle time, that will be 2. Is this clear? So 19, that is in of the next job, and subtracted from the out of the previous job. That will give you the idle time. This will start at 19. 19 plus 12, that will give you 31. So when should I start? Now there's a tie between this out 31 and this 31. Okay, so this will start at 31. Okay, and the idle time will be 0. Processing time plus 10 gives you 41. This will be 0. 31 minus 31 gives you 0. The next job will start on machine number A at 31. 31 plus 15 will give me 46. Okay. Now you can compare these values, 41 and 46. Greater is 46. So this will start at 46. 46 plus 10 is 56. Subtract 46 from 41, you'll get the idle time. So that is 5. The seventh job will start at 46. 46 plus 9 gives you 55. This 55 and this 46. So B is not idle. So it will wait. Greater is 56 compared to 55. So 56 will be the in for job number 7 on machine B. 56 plus 3 gives you 59. And as both the values are 56 minus 56 will give me 0 as the idle time. The last one. Now, this step is again important, especially for A. Now, 55 will be the in for the last job, large number 6. Okay, plus 11 will give me 66. Now, when compare this to machine B is actually idle, so it will start at 66. Now, when this job number 6 starts on machine number B, okay, whatever time it takes to complete this job, that will be the time for which the machine number A will be idle. Okay, so this will take only 1 year. So total is 67, and the idle time for machine number B will be 66 minus 59. That gives you 7. And what is the idle time for machine number A in this case? That will be only 1, because it is taking only 1 hour to complete this last job. Okay. So when we do the calculations, let us see the calculations. So the total elapsed time will be the last value here, the last job which got completed on the last machine, that is 67 hours. Okay. And the total idle time will be equal to idle time for machine A plus idle time for machine B. Now, idle time for machine A will be this value minus this value. So 67 minus 66, which is 1. And you can add this up, all these values. So 3 plus 0 plus 2 plus 5 plus 0 plus 7. Okay, that is 17. And the total idle time will be 18 hours. And please remember, this is the optimum solution. Okay, I hope you have understood this type of a problem. So when we come next, we will solve a problem where we have 3 machines and n number of jobs. So processing n jobs on 3 machines, that is what we are going to check. Any doubts, guys? Fine, then we'll stop here for today. Please go through this video again if you have any doubt, especially all the steps. Okay, it's very simple. Once you get the sequence in which we have to assign the values, okay, you'll be able to solve these problems in very less time or very quickly as well. Okay, so let me